How it works, pneumatic piston. So the basic concept behind this pneumatic piston is you have two inlet channels. So compressed air at 95 psi is pumped through channel 1. This in turn drives the piston forward. The force produced by this will be the pressure of the air times the area of the piston. Compressed air at the same pressure is pumped through channel 2, driving the piston backwards in the negative x direction, developing a dynamic model. In order to develop a dynamic model for this system, we need to measure a few variables. The first one, according to the pressure gauge, the pressure going into each nozzle was precisely 95 psi. Next, the area of the piston had to be calculated by estimating the diameter of the piston. The third measure variable was the mass of the platform. To develop the equation of motion for this system, we simply use the conservation of mass, which states the mass flowing into a system has to equal the mass flowing out of a system. Using Newton's second law and the conservation of mass, the following equation for motion was found. By solving the Laplace transform of the equation of motion, the dynamic response was found using MATLAB. As you can see from the graphs, there are multiple spikes in amplitude. This indicates the dynamic response is an impulse response, which makes sense because the pressure nozzle inputs are releasing a fixed amount of pressurized air to the piston in the pneumatic cylinder in very small increments of time.